we've got an hour and a half or slightly less than that now with all my faffing about to talk you through a little bit about what the APC do. So this is going to be an opportunity for those of you who don't know what we do. I'm going to provide a little bit of an oversight. Then I'm going to be joined by my colleague John Regnart, like I said, who's the Automotive Trends Strategist at the APC, who's going to walk you through the roadmaps that we recently updated and refreshed on behalf of the UK Automotive Council, picking out key areas that will probably be of interest to many of you present here today. And then finally, Ruby Akhtar, who is our one of our business relationship leads at the APC, is going to talk through the funding process. So really helping explain to people, if they are interested in accessing some of the funding, the different routes that there are that they can get involved in, so that they can pick up with us post the events. So let's just go to the next one. So a little bit of an APC overview from me. So initially, as we know, the UK has made various commitments out to 2050 to reduce the emissions from our transport sector. And we know that this is going to have a significant impact on the UK automotive supply chain as it helps with that transition. And really what we're here to do is help support that trajectory and see how we can work with the likes of yourselves attending this event to really help you transition those businesses and see where the opportunities are to meet some of these challenges and really ensure that the UK remains competitive in the landscape. So really, we know that transport accounts currently for 28% of the UK's greenhouse gas emissions, which is double the amount that is currently produced from our UK homes. So really looking at how we can address that. And we know that transport is a sector that is lagging behind. So we can see that our energy production has come down significantly by the addition of a lot of renewables. That obviously, being on an island and being rather windy, I wish we had more sun, really. I don't know about you, but I'm in the Midlands today and it's very miserable, and we've had a hailstorm just recently. Sure, we've got bright sunshine up there though in the northeast, but it's something that really with sort of decarbonising our grid, and we can see that, you know, really, I'm sure many of you are familiar with this, transport has almost remained static at the moment. And so really looking at how we can evolve this and help reduce those emissions from that sector over the coming years. So APC were formed in 2013, sort of at request of the relationship between industry recognising that it needed to do more around the decarbonisation agenda and working with government to help supporting the de-risking of some of the investment required in some of the technologies that would get us on that journey and support the UK sector itself. So really we're here to help experts with expertise. We've got many people that have worked across the different sectors, and particularly have got backgrounds as engineers in the automotive sector. So we're here to work with those companies and consortiums to really develop the right products in the future. We identify where potential investments can be and help companies develop their strategy. So John will touch on that with some of the roadmap work that we're doing. We have our national networks that I'm talking about, which are focused around the 6 technology areas, really looking at bringing communities together and seeing again where we can share that insight. And actually often we see a lot of transitioning across the sectors. So the networks aren't always focused around automotive, and actually what we're seeing currently with the transition to some of these lower carbon solutions is that the silos that traditionally existed between the sectors are being broken down as we recognise the opportunity for disruption and innovation as we collaborate more efficiently across those groupings. We help to build the projects and consortia, so Ruby will touch on that as well and talk a little bit about bringing those organisations together. Our consortiums for the CR&D projects have ranged, I think the largest we've had is 15 organisations working together, and the smallest is sort of around 1 or 2 organisations working together, so they can vary significantly in size depending on the project and the scope. All our funding is matched by industry, so it is that real relationship between the public purse and what industry are doing to really demonstrate the opportunity of de-risking some of the challenges, but ultimately we're there to support the decarbonisation of the technologies, and also supporting the transition to autonomous vehicles as well with our sister organisation Zenzik, and I will just briefly touch on that at the end. Hi John, good to see you there, join us. I just popped on there. So really we are delivering a sustainable impact, and since the formation in 2013 we've supported over 150 projects, so helping businesses across the passenger car, off-highway, heavy-duty areas to really look at these technologies and how we're doing. It's involved, I've talked a lot about consortium, and really with the accelerating progress, that collaboration is key. And we've worked, the projects have had over 375 project partners, and really our measures, if you like, in terms of are we fulfilling our KPIs, if you like, given to us by the government, are looking at the safeguarding and the creation of jobs. I think the recognition that the UK has a very strong heritage around the internal combustion engine, so really looking at how we can support the transitioning of those skills into the future markets, and adapting the skills that we currently have within our engineering and manufacturing workforces, and how we can help with that transition towards these newer low carbon technologies is something that we are really keen to see happen within our projects. And the savings of 260 million tonnes of CO2, which essentially is taking cars with nasty harmful tailpipe emissions off the road. But one of the key things, and I really like the fact that, you know, there are already over 1 million cars on the road that are using APC funded technology. So really seeing it come to a reality from being that sort of, you know, right through the life cycle, from research and development and the testing, and then the manufacturing and scale up, and really having an impact on the supply chain. So I'm looking forward to seeing some of those impact figures that we're working on currently as well, to see how the organisation is transitioning the sector. You can see from this slide, there's just a large range of organisations that we work with. So we do cover everyone from the passenger car side of it right through to some of the smaller businesses. So I'm sure some of you are familiar in your region, obviously there's Avid and people like that, but looking at, again, where we can support the transitioning of the technologies in terms of the growth from the smaller business, and looking at actually, can we have more tier ones and grow our own tier ones here in the UK to support this sector as we are starting essentially on a level playing field globally. So really, we're here to help build that longer term future. So really looking at the sustainable vehicle production and looking at the growth of the supply chain. I think traditionally we had some finger pointing, I'd say, in the early days with some of our first APC projects, where it was very much supporting the large OEMs. But as we've transitioned through the timeline, actually going into more depth around the supply chain and where we can add value and support those further down the tiers to look at the development and the access that they may need for funding is something that we've done and are doing more of. It's very clear that we need to support the direction of travel in terms of reducing those harmful tailpipe emissions. But by doing that, and those of you that know me will know that I'm very passionate about life cycle analysis. You know, let's learn from our mistakes where we pushed everyone down one particular technology, and by pushing people down a zero tailpipe emission, let's take the opportunity to look across the life cycle and look at both the decarbonising of the grid, which obviously Colin has previously touched on, but really looking at reducing those emissions about what we're using when manufacturing our products, but also thinking about the materials that are being used in the development of these components, and actually how recyclable are they, and how can we retain the value within some of these products, either through reuse or reusing within another sector, and looking at how we can start to use one sector's waste stream is another sector's resource, and really looking at that transition and thinking more in a life cycle way to mitigate our impact to the world and the environment, but also thinking about the wider sustainability agenda, not just the environmental, but also the economical and societal impacts too that our technologies could have. But ultimately, we're here as the APC to fly the flag for the UK, to celebrate others and what the automotive sector can do here in the UK. It's about building those relationships with our international counterparts, and really looking at where we can help fill and plug gaps in their supply chain. So we do a lot of work with the guys out in Japan and China and Korea, and even with the roadmaps that we have refreshed that John will talk about. We're just getting these translated now to help form the strategies and begin those conversations with other organisations internationally to make sure that they know if they come to the UK where they can find the skills and the capability that we have in large amounts here. So really delighted again to link with the region, and I know there's a lot of capability here in the Northeast. So just to touch on some of the key areas of the portfolio, funding is traditionally the one that essentially we are known for and have evolved from, if you like. So this is something that we pulled together to help people understand the funding landscape. We're often targeted, or the business development team are often asked, you know, where we fit, who do they go to, and where do they get the insight from? So we just pulled this together. So obviously at the front and the low TRL levels, you have the EPSRC, so a lot of the academic research here will be carried out through the universities, which will then be pulled in through many of the Innovate UK programmes or the IDP programmes that I know many of you will be familiar with, and that which is sort of in the TRL 3 to 5 area, and then that will flow through into our traditional APC CR&D programmes, and then in the latter stages to the Automotive Transformation Fund, which is where the industrialisation and strategic interventions can take. And like I say, I'll touch on that in a little bit more detail in a couple of moments. But you know, what's really exciting for me is the opportunity that we have in the UK, and why the UK is attractive because of the other areas of funding that we have as well. I know Rachel Absina here is come and been talking to you about the Driving the Electric Revolution. So that was obviously formed in 2019. I was delighted to be part of that team that pulled that proposal together, and really that is, you know, supporting the growth of power electronics, machines and drives within the UK, and we very much signpost towards them and also work aligned with them and with the centres to make sure that we are helping industry develop the technology at the right time and with the right people, and helping them access that funding where necessary. We also work very closely with the Faraday Battery Challenge, again, which is obviously with its Faraday Institution, as Colin touched on, looking at the new materials that could be used within our battery chemistries, and again, working with them, looking at the scale up and working very closely with the UK Battery Industrialisation Centre, again, to look at that whole ecosystem. I think it's really important that we aren't seen as competing funding organisations, and we believe it is very important to have good alignment with each other, so that we know that we are picking up and taking all of the industrial players on the journey together through collaboration, and making sure that nobody falls through the gaps, and making sure that we are signposting in the right areas and helping form those consortiums in the right areas. So really that's something that we're keen on, and again working closely with our other funding organisations. So really with the government's announcement around the cease of sales of the internal combustion engine by 2035, the sense of urgency is really hit home with individuals on how we help develop the sector and move the market forward. So we have our CR&D competitions that are open, and again Ruby will talk about that a little later. Our current APC 18 call is open, and that looks around the match funding marks from anything from 5 to 40 million. There are usually 2 to 3 competitions a year. Again, we try and work with the other funding organisations to try and reduce the amount of clashing there is, as we know that it can be a competitive landscape, and we want to make sure that people can get picked up where appropriate, and have a good spread of funding throughout the year that they can access. There is then the Automotive Transformation Fund. So this was announced in 2020 in June, and really this was the recognition that to support the development of some of the requirements, so things such as gigafactories that we'll need going forward, there needed to be some strategic investments made, and the government recognised this and wanted to demonstrate to some of those key organisations out there that we could help support and de-risk some of that activity. So the team are working very closely, and due to the fact that the APC has a great relationship with industry and is recognised for its integrity, we do form those strong relationships with organisations who may be looking to come from overseas to invest here in the UK, and work with them on understanding where in the UK may be a good fit to meet their demands, whether that be something to do with getting access to the right skills, partnerships with academic institutions, or access to things like low carbon and green energy. So really looking at helping these organisations join some of those dots together and support the growth of the UK activity, but also signposting to them where they might get access to some of their critical and their raw materials to support the development of their technologies. So really the Automotive Transformation Fund is focused around the key areas that you would expect, so batteries, power electronics, electric machines, and also fuel cells. But as also touched on by Colin in his latter part of his presentation, recycling is in there. The recognition that, you know, there is something that we need to do in this country to support the recycling, as we don't have a lot of those key raw elements to start with. So actually, what can we do to retain them within the ecosystem once we have developed the products within there? And so really looking at some of those opportunities around recycling, and again touching on the need to think more sustainably and to take a life cycle approach in some of the design and activity that we do. We also have our Technology Developer Accelerator programme. Unfortunately, this round is just closed. The fifth wave is just closed for that. Expectation is there'll be one open again later in the year, but this is there to support startups and spin outs of businesses to really help them find the right market. You know, is their product really suitable for a particular market they're thinking about, or is it do they need a bit more advice in terms of investment, or are they looking for an end customer? So we really work with those startups and spin outs to think about, you know, their business models, to offer them both financial support, business support, or even just insight into some of the technology and how to scale up their development going forward. And again, I think one of the key things here is the TDAP programme doesn't necessarily have to be within the automotive sector, and it has often helped companies work within, say, some of the other sectors such as aerospace. More recently, and partly due to that impact that we've had in terms of being a trusted member and building those relationships with industry, is we've developed a lot of insight around the business, and that's something that has become more and more stronghold about the organisation and how we are trusted, and I suppose the reasons why the government has trusted us to help with the distribution of the funding through the Automotive Transformation Fund, to really work with those organisations to help them see where the opportunities are. So John will go into more detail around the technology and the product roadmaps, but again, working with a great deal of organisations in industry and academia to develop these, and not just UK focused, but also international development. And like I say, we're just in the process of translating those to make sure that they are used far and wide across the globe to support and demonstrate the opportunity potentially for engaging with us in the UK. The technology trends team have also done a lot around the supply chain piece. So really looking at where the opportunities are around the passenger car market. And one of the things that they did was produce this report back in 2020, looking at what the opportunities were. And over the course of a 5-year period, they believe that there is an addressable market of around £24 billion worth of opportunity, and they are split into three key areas, as you can see there. And again, as touched on by Colin, and some of the access to those materials that you have. So as you start to dig down the supply chain, and a piece of work that we did through our electrical energy storage spoke, working with E4Tech, we found that the battery chemistry side of things here in the UK is well placed, and we do have a lot of key elements that are required. So the opportunity there comes out that there is a great area of growth here, and again, things like this report support things such as the Driving the Electric Revolution Challenge and both Faraday Battery in terms of where some of the research should happen and where some of the investment opportunities are. And I think that's a key aspect of the whole ecosystem, and again, the real opportunity for the sector as we move forward. We then have our national network. So these are our building our communities. They specialise around the technology areas, and they're very much looking at joining up industry and academia together. So we have 6 spokes, we call them, around the country. So we have electric machines based out in Newcastle. We have power electronics in Nottingham. We have electrical energy storage or batteries in Warwick. Digital engineering and test in the London office, but operated and managed by Loughborough University and the Institute of Digital Engineering, who have actually just recently published their digitalisation roadmap, which is the first of its kind. So some really great insight there, again, around the opportunities around modelling and simulation, and opportunities around digital twins as well, that I'm sure some people will find very useful on this call. And then we have 2 thermal propulsion systems spokes. So the engine community, one down in Bath, which has just recently opened its advanced propulsion systems institute, which is again looking at the testing of the hybrids, and again looking at the opportunity of where industry can get some of that testing done. So some really good insight there. And then the thermal propulsion thermal efficiency, so led out of Brighton. And again, these groups bring together industry and academia, and we run a number of different events. Currently doing a piece of work with the guys at Newcastle, looking at, for example, life cycle analysis around the electric machines side of things, recognising that from a life cycle perspective, we have quite a lot of information surrounding the batteries and also around engines, but in some of the power electronics and electric machines, there is very little in terms of publications, some of the challenges on how we mitigate the embedded carbon within those products, and how we can improve their design, and again reduce their impact, or indeed look at where we can retain the value in some of the key elements within those motors. It's also recognised, and some work we did through these spokes, that whilst electrification is seen as a viable solution for a majority of our passenger car market, there is the other sectors and the transport sectors that are accountable for that 28% of greenhouse gas emissions that will be more of a challenge to decarbonise. And actually, so what we did was we formed a transport energy network, which was led by our thermal propulsion thermal efficiency Brighton spoke, to really look at what the opportunity was across the sectors. And the reason that we did this was really to start looking at how we could aggregate the demand, if you like, for things like fuel cell technology, or where investment needed to be made. One of the challenges around our other transport modes, so things such as aerospace or maritime or even rail, is the lifespan of these products. You know, they aren't refreshed so readily, so actually looking at how we can either retrofit technologies or use alternative, say, sustainable fuels within them is something that we need to look at, and again to work together to try and up the volume. So this looks out to 2050, and again you can see here, this is just one of the screenshots from the report that again looks at where you get the different trajectories and the transitioning period over time. And again, one of the things we've seen there is some great work happening across the different modes of collaboration, say with maritime and rail, and again bringing in some of the heavy duty guys. So really, again, opportunity for the supply chain to grow and develop, and actually with the focus being less on the primes and the OEMs, and further down into some of those SMEs who may have disruptive technology, and again who can support the wider transport sector. And then one of the things that I wanted just to signpost was the other insight piece that we do. So from the spoke side of things, we have a battery recycling report that was done again, and this was done by the guys at Warwick, and again you'll be able to access the link here, and it touches on, and I know Colin touched on a few of the numbers already in here as well, and I think the key thing here is that there is an opportunity, and this report breaks down what the current landscape is around Europe in terms of the type of recycling facilities that there are, and really what they are recycling, and how to understand what they're doing, and actually where there is an opportunity for investment within the UK to grow that capability. And to me, I think that, you know, out to 2050, the recognition that 2040 this is, that recycling can supply around 22% of the demand, and that is assuming that, you know, we are looking at having a 60% recycling rate, and I think that is a real opportunity again for the UK when we start to look across how we join some of these dots up across the country. There's then the autonomous mobility side of it. So this is our sister organisation, Zenzik, who again are looking at the opportunity. The UK is very well placed for autonomous technology. Again, I know there is a test trial going on in Sunderland looking at this. And again, one of the things that we're looking at doing is creating the connected and autonomous mobility testbed, again, to demonstrate that the UK has great legislation for people to come and trial their technology here, but also we have a lot of disruptive startups who are seen as key leaders in this area. So looking at how we can help develop and support them with their trajectory and hopefully the export of their technology. The final thing that I wanted to touch on, and just to raise people's awareness of, is that we're supporting COP26. And on the lead up to the event in November, we are looking at running a series of events called the Road to Glasgow, very unimaginatively named, and working with organisations. Again, many of you're here today. NEA, you know, invited as part of it, and DER, for example. And we're looking at how we can demonstrate the real value and the opportunity that we have in the UK for driving competitiveness, but also to help achieve the ambitions that are set globally on reducing our overall emissions and helping to protect the planet. So without further ado, I will then pass over to my colleague John Regnart, who is going to give you a little bit of insight into the roadmaps.
Are you driving, Philippa?
I can do. I can be your. You can be my Chris Whitty.
Okay, brilliant. Cool. So thanks everyone, and thanks Philippa for introducing APC. So what I'm going to be speaking about, so first of all, my name is John Regnart. I'm the automotive trend strategist at the Advanced Propulsion Centre. So I have two roles. First one is updating product and technology roadmaps on behalf of the Automotive Council, which is what I'll be speaking about today. And then my second role is looking at opportunities in the UK supply chain, especially in electrification. So that's batteries, motors, power electronics, and more recently fuel cells. But today I'll be talking about roadmaps, and I'll intersperse it with sort of some opportunities and analysis interspersed over the roadmaps. So next slide, please, Philippa. So sort of structure of my talk today, I'm going to quickly go over the roadmap collaboration process, because I think it's important just to talk about the amount of organisations, both in the UK and globally, we got involved in to give their opinions on the update. It was sort of over 140, so it's good to talk about that. Then I'll move on to the product roadmaps, just sort of give more of a helicopter view of what's going on in the passenger car sector. And the product roadmaps actually went through a really big change compared to the ones in 2017, 2018. And then I'll spend a lot longer on the specific technologies identified in the roadmaps. And what I intend to do is not talk about very specific things around how technology will evolve. I'm taking broad technology categories and just explaining what the opportunities are in subcomponents and sub-manufacturing processes from the perspective of if you were transitioning from perhaps an ICE or chemical or electronic sector, some areas that you potentially could get into that kind of are adjacent to those sorts of sectors. So that's kind of the structure of my talk today. So next slide, please, for that. So a bit around the collaboration process. So a bit about the roadmaps first. As I mentioned, there's product and technology roadmaps. So a product roadmap basically refers to a vehicle. So the APC has responsibility of updating 3 product roadmaps. That's light duty vehicles, so that's cars and vans under 3.5 tons. That's heavy goods over 3.5 tons and off-highway vehicles across the whole weight category for off-highway vehicles, and then bus and coach as well. And these are all distinct mobility sections, and I'll go into a bit more detail about kind of how we categorize those. Then we have technology roadmaps, and technology roadmaps feed into the various product roadmaps, and they look at the specific evolution of the specific technologies. So electrical energy storage, which is about batteries, power electronics, electrical machines, lightweight vehicle and powertrain structures, fuel cells, which was a new roadmap for 2020. Historically, fuel cells had been embedded with thermal propulsion systems, but we've split those two out now to give it, just because of all the investment that's gone into fuel cells the last sort of 18 months or so, it warranted its own kind of automotive dedicated fuel cell roadmap. So that's kind of the split between them two, and as I said, the road mapping activity is supported by the Department for Business, Energy and Industrial Strategy and the Automotive Council as well. Few health warnings on what a roadmap is supposed to do and what it's not intended to do. So the APC, also Council roadmaps, have always had a global perspective with a sort of EU perspective twang embedded into it, but we've tried to take the considerations of perhaps what's going on in the Japanese and US market as well. But really the power of the roadmap is who came together to sort of decide or provide a snapshot at the point in time. And actually they provide a common foundation for academia, industry, government to look at a document and go, okay, well, that's what the automotive industry thought in kind of 2020, and we'll base our research and future internal road mapping based on those. But what a roadmap's not intended to do is to understand what the UK capability is in addressing some of those market opportunities, and they don't map out what the skill requirements should be or how we need to ramp up the supply chain. It's kind of a bit more agnostic to just show where the technology is going. And perhaps most importantly, what it isn't a lobbying document. It's, you know, the launch coincided with the 2030, 2035 announcement, but we always say it's a snapshot at a point in time of what the industry consensus is in the world, basically. So yeah, it's not meant to go into any sort of lobbying process. So we sort of canvassed a broad section of the automotive supply chain, from tier end suppliers, a number of different OEMs spanning passenger cars, off-highway and heavy goods vehicles, number of people in academia and other trade bodies representing various sort of clusters that you would expect in automotive sector. So one of the challenges with this roadmap update is that we did it through the pandemic, but with that sort of difficulty came an opportunity to broaden the horizon, because we did a lot of the work through online collaboration software Miro, and actually it gave us the chance to talk to a few companies and personnel based in Japan, the US, Germany, and other European countries. And whilst predominantly the people that we surveyed were UK based, a lot more this time came from more international representations. That was a really good point of this roadmap, is that we got our thoughts sort of stress test against international audiences. So I've got one more slide. Yes, so kind of why should you read a roadmap, and what value does it bring to you? So I've kind of defined 3 reasons why in these particular roadmaps and the reports you should read them. They'll tell you how the performance of certain technologies evolve. So what's the expected cost, energy density, power density of batteries moving forward. And again, for e-machines and power electronics, it kind of gives you an indicative spec and what e-machines and power electronics may kind of be moving forward as well, in terms of voltage, power, etc. It also, the second point is that it gives you a really good understanding of the broad categories of innovation that occur in certain technologies. So the green bars that you see on roadmaps, they're very specific, but the fact that you can look at the categories and go, okay, well, where do I maybe fit in, is powerful, and it aids an understanding of the technology from, right from sort of government people right through to those who want to transition into the electrification sector, can kind of understand some broad themes. And then finally, the roadmaps they perform quite well in understanding how technologies evolve for different sectors. And a key theme of the roadmaps this year was that, when we talk about a battery is different whether it's in kind of high volume passenger car compared to if it's going to be in a heavy duty vehicle or in a bus, and they're 2 different animals. And that has a sort of technology implication and innovation implication based on what end sector you're looking at. And I think the roadmaps pull that out a lot more clearly this year. So that's sort of the process side done. Now I'll talk a bit more about the content side of the product roadmaps, and I'll focus on the light duty vehicle roadmap. And the reason being is that kind of where electrification is going to be the most prevalent. So when we constructed the roadmaps, we quickly found that actually looking at vehicles from a power versus energy lens was actually quite a good way of kind of mapping out the various vehicle sectors. So on the kind of low power, low energy end, you have the light duty vehicles. In the high energy bit and medium power, you kind of have buses and coaches, so they have long duty cycles, or have to operate for a long time, and so they're quite energy hungry, but the power is kind of constant. It's not massive, but it's not small amounts either. And then on the high power, high energy, you've got sort of 44-ton truck vehicles and big off-highway equipment, and they're industrial workhorses. They're in the field of operation for a long time, so they have high energy requirements, but also they're either ferrying rocks or digging earth, so the power requirement's quite high as well. So, and it was a really good way, as when we moved from internal combustion engines that they can do all the power energy range to needing to understand duty cycles and power and energy. It's a very good way of phrasing it when we move to looking at hydrogen fuel cells, electrical, batteries and stuff. So that's a big change from the previous way of looking at it. So go to the next slide, Philippa. So when we kind of looked at light duty vehicles through that lens, we kind of did or created 3 subsections of the light duty vehicle roadmap. So that was urban mobility, which is typically low power. and the types of vehicles you'll see there are A and B segment vehicles and small urban BEVs, so the last mile delivery vehicles. You then have long range mobility, which is slightly more power than urban mobility. So things like local vans, but also high volume passenger cars of C segment and above kind of fit in that segment as well, that need to sort of go into city. And then you have high power and performance. So these are high powered vehicles that have high power for two reasons: either to augment, and people like sports cars and the performance element, or actually the power is needed to perform a function like towing, or off-road capability, or in an American market, Ford F-150 is quite a power hungry vehicle. So the market dynamics there require higher power passenger cars effectively. So and that's different to long range mobility. So those are the three broad categories. So when we start looking at the powertrain trajectories for them in the next slide, what we'll see is that the things to notice are, in this version of the roadmaps, we've documented energy source. So there's a recognition that any form of powertrain or any form of mobility is intrinsically linked to the energy system, and we need to start thinking more holistically about, okay, well, we're not getting everything from oil now. There's an electricity grid implication, a hydrogen production implication, and potentially for some vehicle applications, is there sustainable fuel angle as well? And those sort of feed into the various powertrain bars on the left-hand side. But also we've given more space to describing kind of technology choices. So a BEV for urban mobility is going to be completely different beast in terms of technology choices that a BEV for high power and performance. So Porsche Taycan lives in high power and performance. It's 800 volts. It's got a really big battery pack with really 500 kilowatt worth of motors in. Whereas if you take a Citroen Amy, that's 48 volts. It's got like single digit kilowatt hour battery and a 6 kilowatt motor. They're both BEVs, but the technology choice is so fundamentally different. They're in different categories, and that's what the product roadmaps are trying to do, is show that differentiation as well. So, and the final slide really is just looking at the trends and drivers that are affecting and impacting upon the products. So this is ranging from localized emission zones, where the CO2 legislation is going to be moving from tailpipe to life cycle, as Philippa was mentioning, that life cycle analysis, but even things around urban mobility changing the way BEV platforms are going to be moving, and the fact that EV efficiency improvement is now a thing that OEMs are eking out to sort of maximize the use of what will be in the medium term scarce renewable energy. And again, you can read this, and this in our reports gives you more sort of information on the trends and drivers affecting automotive sector. So that's really the product roadmap. So I now want to go into the technology roadmaps. So let's start with electrical energy storage. And at the start, and a theme that I've said is that a battery, isn't a homogeneous thing. There are different types of batteries for different applications, and what the technology roadmaps have done for batteries, motors, and power electronics is defined different applications of batteries. So I won't go through them, but what the radar plots here show quite nicely is that how certain things prioritize low cost, certain things prioritize power density, and certain things prioritize volumetric and gravimetric energy density, and that will dictate certain technology choices. And we try and bring those out in the narrative of the roadmaps as well. So if we go to the next slide. So this is the modules and pack element of the roadmap. There is a cell materials and manufacturing, which is before, but I thought I'd illustrate here because I think in the modules and pack element, there's a lot more synergy with the existing kind of automotive supply chain. And there's a lot of areas where existing automotive suppliers can get involved in the pack and module assembly element of it. So there are 6 broad themes. on the left-hand side, and that's cell formats and design. So how do you design a cell? Electrical distribution system, which is just effectively the BMS and how you manage power, how you get the power out of the cells to the motor. The thermal management of a battery and heating up of a battery if you're in a cold climate. Mechanically, how do you keep the battery safe and construct it, sort of make it more lightweight from a materials perspective, and then how do you integrate that into the pack integration and manufacturing is how do you get the cells into the vehicle in the most efficient way possible and not add additional thing that doesn't add to energy density. And throughout all of the technology roadmaps, we also have a life cycle element to things as well, because you'll see a theme through APC thinking is that life cycle is inherently important to how OEMs are going to be thinking. So specific examples of things that manufacturing processes and components on the next slide are. So looking at electrical distribution systems. So on the right hand side, there's a really handy sort of explosion of what the key elements are in a battery pack. So this is taken from a APC electrical energy storage spoken WMG report. So on the electrical distribution sort of system, components like low voltage connectors, buzz bars, you need a whole load of voltage, current, temperature sensors in batteries, expertise in software and data science and algorithms to enable better battery management systems to manage kind of the temperature and voltage is needed. Things like wiring harnesses are a big component of some of the battery pack costs, and integrated circuits where the sort of magic happens, the ASICs for BMS systems as well. So any people making integrated circuits can go into BMS. On the thermal side, again, so battery packs like to sort of stay the same temperature range as a human. So thermal interface materials that sit in between the cells, cooling fluids that if you manufacture kind of those for engines, or if you're a chemical company, then they're needed in batteries, but things that are safe in an electrical environment, and insulation materials. In terms of pack integration and the mechanical stuff, so a lot of manufacturing processes that are familiar to the automotive sector also occur in module and pack assembly. So, laser welding, plastic injection molded components for sort of the module assembly, aluminium sort of structures, pack cases and battery trays, and also increasingly composite structures as well are going into battery packs. So again, a lot of kind of opportunity there. But equally on life cycle and end of life, so those companies doing chemical separation, the metal recyclers, as well as a lot of at the moment the biggest weight contribution to batteries is still kind of some of the pack stuff as well, and highly automated equipment as well. So some of the software that controls sort of robotic machinery is interesting to try and extract some of the cells. Is that the recycling report that Philippa illustrated, they say the biggest cost of recycling a battery is actually the labour. So trying to automate that as much as possible, and designing battery packs for end of life is critical. So those are just some of the examples on battery packs. So moving on to fuel cells as well. So again, the fuel cell is kind of five key elements. So a fuel cell stack, which is kind of where a lot of chemical IP lives in the fuel cell stack. The balancer system is kind of a lot of traditional ICE kind of components can live in there. So if we go to the next slide, actually, I can sort of blow out what's involved in there. So in the fuel cell stack, whilst it is materials IP intensive, there are some manufacturing processes in there that lend themselves to what happens in traditional automotive. So bipolar plates can be stamped, they can be chemically etched, hydroformed, injection molded, and then for the gas diffusion layer, which is basically a carbon-based material, that needs to be sintered as well. So opportunities there. In the balance of system, there's so many components here that you could just read off what is needed for engines, but compressors and blowers to turbocharger manufacturers have an opportunity here just to move their products from ICE to fuel cells. It needs things like valves, actuators, radiators and cooling pipes and heat exchangers are needed. Even humidifiers and water recovery systems are really, really important for fuel cells to control, you know, to recover some of the water, so it doesn't damage the fuel cell. Again, sensors, but also injectors to inject the hydrogen into the fuel cell as well. And some companies are looking at kind of transferring their know-how in ECU control for injector systems for engines into fuel cells. And for fuel storage and management, so one of the biggest costly items on a fuel cell vehicle is the carbon composite tank. So anyone kind of making carbon fiber materials is onto a winner there, and anyone who can filament wind the carbon storage tanks as well, really lucrative area. And there's a big opportunity for solid oxide fuel cells for onboard reformers as well, that can kind of purify sort of fuel, so it can then go into the fuel cell. So those are some of the opportunities in fuel cells. Moving to electrical machines, so a similar concept to what we did with batteries. We kind of articulated 3 different electrical machine types that all prioritize certain things, and based on kind of the energy and power demand that particular end machine goes into. So you can read more about that in the report. But when you go into the roadmap, the narrative report explains kind of where a technology would be more suited to a low-cost application, or maybe this innovation would be sort of more suited to a higher performance application. So particular manufacturing routes and components that are interesting for electrical machines. So on the next slide, I've listed a few things. So for machine architecture and integration, there's system integrators, so the consultancies like AV, but anyone who's got experience in integrating machines together, it will do well here. Modeling and simulation, and that kind of is given across quite a lot of sort of these technology areas, but modeling and simulation on the machine side is actually, there's a lot of electrical, mechanical, and vibrational things going on in an electrical machine. Those making bearings and axles and shafts, also kind of in the architecture and the integration to the machine. Similar for batteries, motors need a lot of insulation and thermal management. They don't like getting hot, so insulation materials for copper windings are needed. Impregnation resins that go inside the sort of stator slots so that the windings don't get too hot. Other things as well, like dielectric fluid or glycol solutions are needed, or oil cooling solutions as well in motors are needed. So kind of similar things. And as we move to integrated drives, you'll need kind of a single thermal management loop as well. So understanding kind of the best thermal material to use between electronics, e-machines and transmissions is another interesting innovation area. In the materials and manufacturing innovations, again, stamping, laser cutting, sheet stacking, laser welding, cleaning are needed. A lot of powder metallurgy and net shape manufacturing and sintering technologies in the magnet supply chain and in sort of the soft magnetics. And then wire drawing to try and kind of get the copper windings. Sort of a lot of casting as well for housings for machines is needed, especially thin-walled casting that can have cooling channels in is a particular requirement. And again, high precision robotic equipment as well that can kind of, so for magnet insertion, where you need to insert magnets into the rotor, you actually need really high precision equipment. So automated robotics again is needed to deliver some of this technology. And similar in the batteries, it's metal recyclers, people that could do chemical separation, etc. of materials are needed as well. And the final technology area I'm going to look at is power electronics. So power electronics is more of a niche, or not niche, it's more of a specialized sector. as well, but there are a few opportunities. So there's 4 sectors, categories there. There's semiconductors, the components that make up converters. There's the converter design, control, and the integration into the vehicle. And again, there's life cycle. So if we go on to the next slide, the semiconductor area is a very specialist area with high barriers to entry. It's millions and millions of pounds of capital equipment with know-how and IP. But again, similar to e-machines, thermal management still needed with voltage, current, and temperature sensors, and system integration skills. But also, kind of, it still needs a housing. So it uses aluminium housing, so that's still needed, and still low voltage connectors and bus bars and connectors are needed. So there's still opportunity there for sort of, if you're in the electronics sector and you want to sort of transition into automotive specific electronics. So that I've done a very much a whistle stop tour of kind of what other components and manufacturing areas can be. If you want to know more about specific technology innovations or the rationale for kind of why we've included something in the roadmap and why it evolves, we have 6 narrative reports that are all free to download on the APC website. And again, very, very detailed commentary on them. It explains the targets, explains the bars on the roadmap. So yeah, they're free to download. So I think that's it from my talk. All I would say is that in the next few weeks is that the APC will be publishing what's called the industry challenges document. So the roadmaps do a good job of explaining when something will enter the automotive market. What the industry challenge document does is say, okay, what are the actual research and industrial challenges that exist to enable that technology to enter the market. So it's used, we intend that it's going to be used for industry and academia to understand what their research agenda should be moving forward as well. So that will be published for each of the roadmaps imminently in the next few weeks. If anyone wants to find out more about what the work Tech Trends does, that our team of Dave, myself, Barwick, and Luke, our emails are there. Just get in touch, and I'm happy to speak about roadmaps and our supply chain work. So thank you all. And now hand over to my colleague Ruby to talk a bit more about funding opportunities and support.
Thank you, John. Philippa, you're okay to drive?
Yeah.
Great. Right, thank you everyone. So my name is Ruby Akhtar. I'm one of the 4 business development team members at the APC. My brief today is really to give you an overview of the funding calls and opportunities we have available at the APC and the application process. Next slide, please. So I know John's touched on the technology roadmaps, but I would look at sort of the scope for the APC projects, the APC competitions, the eligibility for the competitions, the application process, and then an overview on some of the questions which the application process calls. And then we'll finish with a Q&A at the end. Next slide, please. So just referring to this slide again, so the APC definitely sort of sit in that far corner of application readiness and industrialization at scale. To set the scene, you could be thinking about potential opportunities within your organization. You may be having interesting conversations with customers, thinking about future technologies and really how to move forward on some of the products that you may be manufacturing today. That we would then look at how we can tap into funding support and really accelerate that development while sort of limiting the risk to the investment. We always start with innovation. So yeah, the key thing in all of these funding calls is innovation. Business as usual doesn't really attract funding. So that's one of the key elements of any funding call. Next slide, please. So, so in the middle, we've got the 4 elements which John's mentioned, and the intelligent mobility petal in grey, which is the autonomous mobility and technology, which Philippa has mentioned in her slide earlier. It's looked after by our sister company, Zenzik. We at the APC then support competitions. We've got a competition, the TDAP competition, which supports SMEs. We've also got the Spokes network and the roadmaps. Next slide, please. Does that come up? Next slide, please, Philippa. So the 3 buckets of opportunities then within the APC. If we start on the left-hand side, the TDAP programme, really a mentoring programme which allows SMEs, startups, or maybe even university spin-outs to really accelerate their route to market with a robust business strategy, as well as some support with IP development. The plan really would be on a project to develop a business model and have some product and technology validation at the end. As Philippa's mentioned, this project runs twice a year. We're expecting the next call to be sort of at the end of the year, maybe September onwards. To date, the TDAP programme has engaged with 57 companies, completed 27 programmes. So in terms of real term, in the real world, this really is the SMEs increasing their headcount by 50% at the end of a project. They're able to allocate time and resource rather than actually match funding as a monetary value. So that is quite important because it could be critical for a small business or a startup to invest such large sums in projects. And the actual scope for TDAP is slightly wider. So we've covered a range of technologies on the TDAP programs, including battery materials, novel motor designs, and also charging systems. On to the middle section then, which is the CR&D, which is also referred sometimes as our core competition. And on our website, you're able to sort of find a lot of information under the core competition section. At present, we've got the APC funding call, which is live and due to close next week. So if we are thinking of any R&D competitions, it might be a little bit late now, but I guess to get in contact now would be great because we could look at the future APC 19 projects and start those conversations. I know the website does have a lot of case studies, but it's worth mentioning we have worked on large projects on our R&D project competitions. We've worked with Nissan on the Nissan Battery Leaf project, as well as with Avid on the Electric Propulsion project, and Hyperdrive on another battery project. Then moving to the right-hand side, which is going up the TRL levels and getting up to industrialization, it's the Automotive Transformation Fund. Again, industrializing at a large scale. The ATF program's been designed really to have that bridge between R&D and industrialization. The program covers batteries, fuel cells, motors, drives, and power electronics. And it also really does support the upstream supply chain development, which we think is quite key in order to obtain global competitiveness in the UK. So the program runs monthly expression of interest calls. We've had 2 rounds of feasibility on the ATF, which allows businesses to do technical and economical assessments on potential large-scale projects. To date, we've supported 30 feasibility studies and have received a significant number of interest and expressions for large-scale projects. We do expect a third feasibility study to be launched later this year, and the fund will be accessed via the APC. I'll run through the inquiry process for the ATF in the next few slides. So this slide then, it covers the main collaborative R&D competition and the scope for the competition. I guess the thing to mention here is that a match funded competition, you must not exceed 50% across the project. If there are research partners or RTOs involved, they are eligible for 100% of the grant fund, but it must be balanced out across the project. But if you do find that once you've calculated your numbers and you're outside these parameters, it's best to give us a call and we would advise you through the steps and sort of understand a bit more about your project. And finally, really one of the important things about a collaborative R&D project is understanding how a project will have spillover benefits. So this includes upskilling and knowledge transfer in the UK. And the key in these projects is really creating jobs and reducing the CO2. And of course, matching up to the key technology areas which we've touched on. Next slide, please. So this slide, it sort of lays out the criteria for any collaborative R&D project. So it notes that you must have an OEM or a tier 1 supplier involved in the project. This is really to ensure that there is a route to market and there's a strong link there that the technology will be able to go straight into market. All projects must contain at least one SME partner. The project scale and value must be between 5 and 40 million, and the duration between 18 and 42 months. So we've mentioned that the competition opens 2 times a year, and if you are interested, you're able to sign up to our newsletter and you'll be able to get the latest information as soon as it's released. Next slide, please. So how can we at the APC support you on your journey? To start with, to understand the scope and answering the scope, filling out some of these applications and preparing the documentation can be quite costly in terms of time and resource. So really, if we have an early conversation, we're able to support and understand how we can align the technology with the scope of the actual competition. Coordinate the process and really talk you through the process. There's filling out the applications, then interviews. So yeah, really helping you prepare for all of those. Providing general guidance on the actual competition, helping you and your consortium understand the value for money piece and how we can build the case for intervention and funding. And also helping and supporting with the formation of your consortium during the bid process. You may find there's a gap, you may need support in identifying a potential partner, and we can then step in and try and work with our network and find you the relevant partner. Next slide, please. So how do we actually get onto the system and start to apply? All of the APC funding calls are accessed via the Innovate UK website, and I've popped a link on the slide, which you should be able to access. Also, a quick Google search does take you straight into the Innovate UK fund page. Next slide, please. Once you're on the Innovate UK site, you will have the left-hand screenshot appear. You are able to search the fund that you may be interested in, but I find that if you pop APC in the search function and then search, you're able to get everything that's available at the APC. The Innovate UK website normally shows all the funding calls across all the industries. Once you've found the right one, click on the competition link, and then it will take you to the left-hand screen. Sorry, the screenshot, which is shown on the right-hand side. Once you're on the screenshot, you can see there's 3 or 4 tabs which are quite important: the eligibility tab, the scope, dates, and supporting information. And sometimes we have applicants apply and not really read any of the content, and it's really useful information and guidance there. So something to note if you are looking through any funding calls. Next slide, please. So once you're ready to apply, you will need to set up an account if you haven't already applied before on the IFS system. And that's really done by looking at the company house number, and it then automatically populates your company name and address. But there is, I believe, a manual option if you are not registered. And if you do have a research organisation as part of your consortium, you will have to enter your information manually, as your business wouldn't be listed on the IFS system. And we'll need to do that so we could ensure that you get the correct funding. Next slide, please. So this slide really covers some of the questions in the actual application form. And it does require a lot of prep. It's not just going onto a website, filling out a number of questions and then expecting a response. It does require you to provide a lot of supporting documentation. So the initial questions really are derived from the business case, the project details, and the case for intervention and funding. The assessment process is independent and technically assessed. So the intent of the process is really to understand the case for funding and tell the story from part 1 all the way up to part 4. The business case, part 1, is where you effectively set the scene, explain the problem and why it's important, the wider market and the supply chain associated with your product, as well as, I guess, some of the indirect benefits. Part 2 of the question covers a lot of the market information. So this here, a lot of applicants do fall over as they don't provide a lot of evidence, and we need a good amount of evidence. And I guess using the roadmaps which John has presented is ideal in this area, because you're addressing a need to the market. Other things that are used to really determine the project scope could include things like letters of support, purchasing commitment, and the size of the market. Part 3 of the initial questions then looks at how the project will be exploited and the value add. So both the supply chain and within your business, it's worth noting that this is one of the highest areas where you could get the most marks, and projects must provide strong evidence on anchoring and growing and showing significant improvement to productivity and competitiveness in the UK supply chain. And then lastly, part 4 of the application process is a detailed spreadsheet, which is assessed by the Bayes analysts and economists. And it really takes into consideration the technical questions and the wider benefits associated and the value for money associated with the project. The key element to really note is that the word count is quite limited on each question. So it's really important that you attach appendix detail, supporting details for each question, and really not to duplicate the attachments. because that could really annoy some of the assessors, and it's almost a waste of valuable space where you could add potentially really useful information. Each client will get a set of guidance when they log into the system, but we at the APC also will be on hand to support that process. We do not assess the projects at the APC, so we are able to independently advise and assist you through the process and really how to convey your points in line with the competition. It may seem obvious, but the assessors can only provide marks to the questions that they are looking at. So if you provide too much information and not really answering the question, you could lose marks, and really it wouldn't be any value add. So then the ATF process is slightly different. It takes an expression of interest and follows a similar format of the questions, but then if you are successful, invites you through a gateway process. Next slide, please. So the ATF process really requires you to register an interest via the APC website. And once you've registered the interest via our funding tool, we can then get in contact with you and discuss some of the scoping of the project. We work with BAYS and the DIT team, and we understand that there are lots of hurdles when we're looking at large investments. So we try to support that journey and try to assist where possible, talk to various agents wherever possible, and try and get the right support for inward investment. Looking at some of the large scale projects then, it really needs to be a strategic fit. So we do look at the overall strategic value of a project, and then we try to support from there. We are trying to create the right landscape to really create a sustainable market in the UK. The fund does not cover a vehicle assembly, and it's not a purely an R&D program. It's more to expand the UK's cell manufacturing capabilities. We have a dedicated team to support through the ATF process, and we have a scope sheet available on our website should you wish to find out more information. Next slide, please. So to summarize then what I've touched on, and some of the elements that both Philippa and John have gone through. The APC look after late stage R&D, and it's automotive onboard technology. We support with advice through the appropriate funding streams. So if we find that it's not within the scope of the ATF, we do try to signpost you to the right funding calls which may be more relevant. John and his team support with roadmaps, and we also are supporting via the spokes network, and we can provide an opportunity for businesses to really showcase their new technologies via some of the big events, the international events in the UK Pavilion. Next slide, please. So I've attached a number of links here. The links take you to the Automotive Fund, the APC roadmaps, as well as allows you the link for signing up to the mailing list. The mailing list will allow you to get first-hand information when some of the competitions go live. And if you've got anything that you'd like to discuss or a potential project, we would advise you get in contact via the info email or the ATF inbox. Thank you. I think that's everything. I'll hand over to Philippa to kick off the Q&A.
Thanks, Ruby. I don't know if Paul's going to manage it.
Yeah, well, I've just come on. I have put in the chat function, if anyone does have any questions, please put through there. But we are on the last session, so happy to take any questions if people want to raise their hand on the participants, we can bring you in and ask questions.
I think John should be about as well. You there, John? Yeah.
Got a strict screaming kid in the background, so no one wants to.
Yeah, sounds like he's teething, bless him.
We've had everything today: children, babies, dogs, IT works, which is great. Just a comment from me before, whilst anyone decides on whether they want to ask a question. I'd just comment, APC have done a fantastic job in the short time